So a factor is a special type of vector which is used to represent categorical data. So and there's two types of factors. There's unordered or ordered. So you can think of this as storing data that have labels that are categorical but have no ordering. So for example, male and female. Or you can have ordered factors which might represent things that are ranked. So they have an order, but they're not numerical. For example, in many universities you'll have assistant professors, associate professors, and full professors. Those are categorical, but they're ordered. You can think of a factor as an integer vector where each integer has a label. So for example, you can think of it as a vector as 1, 2, 3, where 1 represents high, and for example a high value, and 2 represents a medium value, and 3 represents a low value. So you might have a variable that's called high, medium, and low, and underlying in R it's represented by the numbers 1, 2, and 3. So factors are important because they're treated specially by modeling functions like LM and GLM, which we'll talk about later, but these are functions for fitting linear models. And factors with labels, generally speaking, are better than using simple integer vectors because the factors are what are called self-describing. So having a variable that has values male and female is more descriptive than having a variable that just has ones and twos. So for example, in many data sets, you'll find that there'll be a variable that's coded as 1 and 2, and it's not easy to know whether that variable is really a numeric variable that only takes values 1 and 2, but the problem is that's not something that's coded in the data set, so it's hard to tell. If you use a factor variable, then the coding for the labels is kind of built into the variable, and it's much easier to understand. So factors can be created with the factor function, and the input into the factor function is a character vector. So here I'm just creating a simple factor which has two levels, and the levels are yes and no. And so x is a factor, and you can see when it prints out a little bit differently from a character vector in the sense that it prints out the values yes, yes, no, and then it has a separate attribute which is called the levels. And so the levels of this factor are no and yes. Okay, so there's only two levels. I can call table on this vector, and it'll give me a frequency count of how many of each level there are. So for example, it'll tell me that there are 2 no's and there's 3 yeses. Now the unclass function strips out the class for a vector. So for example, if I call unclass on x, it'll kind of bring it down to an integer vector, and you can see that underlying the factor is represented as 2, 2, 1, 2, 1. So yes is coded as 2, and no is coded as 1. Now it's not really essential for you to know this because you can just treat the factor as being a vector of yeses and nos, but sometimes it's useful just to know underneath kind of how factors are represented by R. And so you can see it's really an integer vector with the levels attribute of no and yes. The order of the levels in the factor can be set using the levels argument to factor. And sometimes this is important because in modeling functions, when you include a factor variable, sometimes it's important to know what the baseline level is. And so the baseline level is just the first level in the factor. And the way this is determined in R is critical. It's determined using alphabetical order. So for example, if I create a factor variable with the elements yes and no, then the baseline level will be the first level that's encountered. And because no comes before yes in the alphabet, then no will be the baseline level and yes will be the second level. Now this may not be something that you want. You might want, for example, yes to be the baseline level and no to be the second level. And then in that case you have to explicitly tell R that yes is going to be the first level. And you can use that using the levels argument to the factor function. So now when I print out the x object, you see that the elements are still the same. They're still yes, yes, no, but the levels attribute is reversed because yes is the first level and no is the second level.